Okay, picking up in lesson 12, graph of log functions. And I don't know if you guys remember anything about logs. Left, right, middle. We're going to talk about left, right, middle. That's exactly what we're going to talk about here several different times. So if you see me write LRM, we're talking left, right, middle, yes? You know that abbreviation. So, and in fact, right here, when we talk about logs, there's two forms. There's the log form, there's the exponent form. Left, right, middle is how you get from log form to exponent form. The left base raised to the right equals, and then it's going to equal the middle. So it's left, right, middle. So B to the P equals N. And that's just getting from log form to exponent form. Doesn't exactly work going backwards. You have to have you have to rethink it, undo it in a way to go backwards. I guess it does, doesn't it? Why did I not realize that before? I think what it comes down to, honestly, is when I go from log to exponent form, I think left, right, middle. When I go from exponent form to log form, my brain thinks about differently. And so, because what my brain honestly thinks is, okay, the base of the exponent is the base of the log, switch the P and N. That's what my brain thinks. It doesn't think about that I could use left, right, middle. So for some reason, I never realized I could do that. I don't know. At this point, I'm going to trust you guys have your ways, or you will review your ways as we go through today.
I just like how it works both ways.
It is. Yep, I agree. Although it's foolproof as long as when you have the log equation, you have the log on the left side. So, okay. Yeah. And there's that if word. Change of base formula. Okay. Change of base formula to change difficult bases to natural logs or the common log, log base 10. But the idea is if you have log base b of x, you can rewrite it. You can either use log base 10 or natural log of x divided by log of b. So it's the log of the insides divided by the log of the base. Now, sketch the graph of y equals log base 4 of x. Do you remember what a basic log graph looks like? I wasn't watching what was here. It's like exponential, but it's officially reflected. So, okay, so if you can visualize the exponential graph, it goes a different direction because exponential and logs are inverse functions. Inverse functions reflect over the diagonal line y equals x. So you'd be taking that exponential and flipping it across that diagonal line. So there's one option. Could we come up with an XY chart if you don't remember, if you're in a situation where you don't remember? And you can. Now, the thing is, log base 4, we can't just punch the calculator button on log base 4, but take this to exponent form. If we take y equals log base 4 of x to exponent form, what is this as an exponent form? Four to the y equals x. And if we do 4 to the y, because it would be left, right, middle if you reverse it, if we set up an XY chart here. Now, normal rule of thumb is we like to say, okay, let's pick random x's. This time, since y is my exponent, it would be better to pick random y values. So I'm going to throw in a negative there. I'm going to pick -1, 0, and 1. You definitely want to have at least one negative so you can see what this graph's doing. And we could pick more, but... Okay, if we put in -1, what is 4 to the -1 power? Did I hear it right? 1/4? Because 4 to the -1 is 1 over 4 to the +1. So 1/4. What is 4 to the 0 power? 1. Anything raised to 0 is 1. And 4 to the first? 4. Now, based on that, and if you have the idea of the exponential graph in your head, you know some basics there. Okay, 1/4 negative 1 says I go right a fourth down 1, 1, 0, crossing through 1, 0, and 4, 1, right 4 up 1. I know it's not a lot of dots. Are those enough to help you remember what to do? The big key is, what's my graph going to do when it runs along the y-axis? Kind of just said it, didn't I? What's my graph going to do near the y-axis? It's going to run along it, right? So this y acts as an asymptote, and we run along the y-axis. It crosses through 1, 0, comes over here, and it's going to go off to infinity at the right. Sound familiar? That's your basic log function. Because Nathan related the exponential function. Well, the exponential function, remember, it runs along the x-axis, not crossing, crosses through 1, 0, and goes up like that, right? So notice there is that invisible y equals x line that these two do reflect over. Okay? This is where I'm just going to hope it's coming back to you here. Okay, what happens if we sketch the graph of y equals negative log base 4 of x? Reflect over which axis? Okay, reflect over the x-axis. If your negative is on the whole function, we reflect across the x-axis. So can I take the graph we just did and reflect it? We can. So reflecting across the x-axis is just going to flip it upside down. So instead of 1/4 negative 1, it's going to be 1/4 positive 1. Still 1, 0. Instead of 4 positive 1, 4 negative 1. Still runs alongside the y-axis. Looks something, you can't even see what I'm drawing. You guys have to tell me when you can't see what I'm drawing. Okay, well, I figured it out on my own. Now, my hope is, though, that you kind of had drawn it on your own. You weren't waiting on me, obviously. I'm going to hope that if you're waiting on to see something, you're going to point it out to me. Let's see here. Debating. Do I need to go through that? I guess the one thing I would say here is if you try and do a left, right, middle, okay, right now there's a negative on the log. In order to do a left, right, middle here, if you're trying to get it into exponential form to do XY chart, that negative on the log doesn't work because we don't have any place for that negative to go. So what you would need to do here is divide the negative to the other side. And so you would have the equivalent equation, negative y equals log base 4 of x. And that works real nicely because now I can take the negative with the y. I have a place to take it. So it would be 4 to the negative y equals x. Anything raised to negative can be taken to the denominator. So 1 over 4 to the y equals x. Just wanted to kind of, give you a heads up. What do we do with that negative when it's on the log? Okay. assuming b is greater than 1. So that's just saying assuming we have a positive base. Because if the base is not positive, it can totally change what the graph looks like. But assuming we have a positive base, graph the following on one graph. So I'm going to color code, but we're going to put all 4 of these on one graph. So, let's do example A, and you can just label these if you want. Example A, I'm going to do in blue. What does the basic y equals log base b of x look like? Basically, it looks like just like our first example of the day. Comes up from along the y-axis. It's going to cut through 1, 0. I really don't like how I did that. And it really should go away from the x-axis more than that. Whiteout is probably not going to be my best friend here, but I feel like I should have gone. Yeah, I didn't make it a whole lot better, but this is my graph A. Okay. What about B? Okay, reflected across the x, so that is just our upside down version. So it's going to start from the positive y-axis, cut through 1, 0, and go off to infinity down below. That's my B option. You guys can't even see my A and B because they're off the screen, but that's all right. What about C? Because the negative is on the x, we reflect it across the y-axis. And so that's taking our original A and reflecting it across the y. So now, basically, instead of being on the right side of the y-axis, we're going to be on the left side of the y-axis. And now you're crossing through -1 instead. So that's example C. What about D?
So reflected across both the y and the x-axis.
Yep, reflected across both axes. So A flipped and became B. You could take B now and flip it across the y-axis. Or A originally flipped and became C. You could take C. I think I said the wrong axis in there, didn't I? You could take C and reflect it across the x-axis. Okay? No, it would have been Y there. So basically, to complete my symmetric drawing, it's the missing piece, isn't it? So this one comes along from the positive, cuts through -1, and follows along there. Okay, so be familiar with what the initial log graph looks like, and be familiar with what those reflections do. Okay. Asked to graph this on a graphing calculator. So we can talk about the pieces. Now, notice it's the absolute value of the natural log of x. I think, if I recall correctly, when we enter this, do absolute value first, which there's a shortcut probably, isn't there? So alpha F2 window. Otherwise, it's in your math menu right now. So I'm going to do the natural log, and I think to get this to work correctly, I have to do absolute value around x as well. So I have the absolute value of natural log of absolute value of x. Okay. Can you figure out what's going on in this picture? If I zoom in, I don't know if that's going to help me or not. Maybe helps me a little bit. Is this one connected graph? No. Okay. It's not one connected graph. It's the absolute value of the natural log graph. But because we have natural log of those x values, it works on both sides. So let me show a picture here. Whether we talk log or natural log. We just talked log earlier. Does natural log graph look any different? I mean, just the fact that the base has changed it this way. So if we just talk about the natural log graph, it looks like something like this, yes? I'm just penciling it in for the moment. Now, if you put absolute value on the x values, because normally we can't take log of a negative, but if you put absolute value on the x values, what's that mean now? You can use negative values. So now my graph exists over here. What's the absolute value do to this? Yeah, it flips the parts that have negative y values and makes them positive. And so that's the piece of what we're looking at. So like this part that's already above the x-axis, it's there. But it's the part that is below the x-axis that has to flip up. Same thing on the left side. And so until you get the right zoom window, you're not going to necessarily realize that's what's happening. Okay. Get what you need there. Then I'll say we can flip to the back side. Example 11. Sketch the graph of y equals negative log base 1/4 of x. What is the noticeable difference that makes the difference in this problem? 1/4. 1/4 is now no longer a number greater than 1. When you get a number that is less than 1, so between 0 and 1, that's where things change. So, we're going to look at this a couple of different ways. First of all, do you remember what I said when there's a negative on the log earlier? If you're going to use the left, right, middle idea, make the y negative. So negative y equals log base 1/4 of x. If you use left, right, middle now, 1/4 to the negative y equals x. What's the shortcut here? How can I get rid of the negative on the exponent? Flip the insides of the whatever that negative goes on, right? So if this is 1/4 to the negative y, it can be really flipped to say 4/1 or 4 to the y. Well, if we go back to log form here, what does this just become? If I go back to log form, y equals log base 4 of x. Do we know how to graph that? Yeah, we already graphed that on the front side, didn't we? So, the point is, this right here, this negative says it's a reflection of log base 1/4 of x. Well, log base 1/4 of x is already a reflection of this. So it's essentially a double reflection. So if I draw this graph, again, this is what we already had on the front side, where we had a point at 1/4 negative 1, 1, 0, and 4, 1. I didn't really leave myself enough room there. What's the graph if it's log base 1/4 look like then? If my original log base 4 of x is just the normal log graph, this negative reflected across the x-axis, but that 1/4 also reflected across the x-axis. So what you need to realize is that the log base 1/4 graph is the one that looks like this. Okay? And that's just kind of helpful information to realize. Okay. One last one, if you will. Y equals log base 2 of negative x. Bless you. So if we want to get official points, what do we need to do? Left, right, middle. So left, right, middle, this is going to become 2 to the y equals negative x. It might be easier. Are we going to be picking x's or y's here? We're going to pick y's, aren't we? So if we're going to pick y's, my recommendation is that you divide the negative over to the other side. And negative 2 to the y equals x. I guess I should probably close the door, shouldn't I? It's a good thing, because by the time I close the door, hey Carter, do you want your water? Or I'll just leave the door open. Okay. So, anyways, my recommendation here is to move the negative over here, and then when we plug in y values, we can tag that negative on, and it works pretty easily. So, if we pick our y values again, negative 1, 0, 1. So if I put in negative 1 here, it's the negative of 2 to the negative 1. So what's 2 to the negative 1 become? 1/2, 1 over 2, and then the negative of that just makes it negative 1/2, right? Now, the negative of 2 to the 0. Anything raised to 0 is 1. This negative in front says negative 1. The negative of 2 to the first, negative 2. So those are the points that you would use. Okay. Negative 1 half, negative 1. Left a half, down 1. Negative 1, 0. Negative 2, 1. And you have a graph that looks like such. Okay? So that right there is your log graph. As you would have guessed, if I would have asked, the negative on the x reflects us across the y-axis. But that was us practicing getting some specific points in as well. Okay, got your log graph refresher? So we can have those fresh in our head there. Finish lesson 12 homework for tomorrow.